Hi everybody, this is Miss Austin and I'm going to be going over the notes for quadratic equations day 1. So quadratic equations day 1, continuing with our deep dive into polynomials today, degree 2. Okay, quadratics are polynomials degree 2. So a quadratic equation is an equation that can be written in the form f of x equals ax squared plus bx plus c. And a, b, and c are coefficients, just numbers. And a quadratic equation can look a lot different depending on if it's been factored, if it's been manipulated. This right here would be called standard form. Tomorrow we're going to look at the forms a little bit closer. Today we're going to talk about how do we solve them. So example 1, it says solve each equation below. Remember, you should find any and all solutions. So let's not forget a quadratic, right, looks like this. So when we see an equation like this and it's asking us like when it runs into a number, depending on how it's been manipulated and what number, it might have two solutions. It might have just one solution, and it's possible it has no solutions, okay? So this first example, it doesn't look like it's in standard form, but if I was to multiply this all the way out, it would resemble standard form. I know it's got an x squared in it, so it's a quadratic, but to solve it, we're just going to use our algebraic techniques that we've been using. We're going to unravel this and get x by itself. So my first move would be to subtract 17. Second move would be to divide both sides by -5. Third move, how do we undo square? Square root, right? And if you think about it right here, what number could I square to make 8? I could square a positive number or a negative number and get 8. So this is where you do consider both solutions. So now we have, I'm going to switch sides. I'm going to put this over here. X minus 10 could produce a positive or negative square root of 8. And then to get x alone, I'm going to add 10. So the solutions are going to be 10 plus the square root of 8, or 10 minus the square root of 8. And you could just, you could leave it like that, or you could find an approximation. 10 plus the square root of 8 is about 12.83. 10 minus the square root of 8 is about 7.17. You could also write it as, I'll show that it's 10 plus or minus the square root of 8. That's showing both the solutions in one statement. Okay? All right, and again, what is that finding? Those are the numbers that if I plug those in for x, they would make this equation equal -23. That's what I just found. Okay? All right, letter B this time. Also, if you might not recognize it, but if you were to do your box problem, that would come out to what? 3x squared plus 15x minus 21x minus 35. And then I could combine those, and you see how that's a quadratic. It's in factored form. Okay, but today we're just, how do we solve these? So remember, if you have two things, and we're going to write this in the box in a minute, if you have two things that multiply to 0, that means either this has to be 0 or this has to be 0. That's the only way. If something times something equals 0, either that's 0 or that is. So we can use that. So I know either this is 0 or this is 0. And I simply solve those simple equations. So one solution is 7. And one solution is -5/3. Right? And these are separate solutions. So like if you put a 7 in here, 7 minus 7 makes this 0. And if you put a 7 here, that makes 26. But 0 times 26 makes 0. So 7 is one of the solutions that turns this quadratic into 0. And then say for this one, if you put a negative 5/3 here, that's going to make this 0. And that's going to make this negative 7 and 5/3. But negative 7 and 5/3 times 0 is going to yield 0. So this problem has two solutions. Okay? And with that, let's write that in a form down here about the zero product property. Okay? If you have something times something equaling 0, then either A must be 0 or B must be 0. Okay? That's called the zero product property. Okay? And so when we see a problem like this, where it's set equal to 0 and it's two things times, then it's super easy to solve. Either that one equals 0 and we solve it, or that one equals 0 and we solve it. And that's how we can find our two solutions. Okay, let's keep going. All right, now this looks more like standard form. Okay, the other ones were kind of set up for us, kind of on training wheels. This one, right, nothing times nothing, no zero product property, and there's no way to combine an x squared and an x. So this is where our review of factoring comes in. Factoring helps me rewrite an expression as a multiplication problem. So here I have a trinomial with a leading coefficient of 1. So this is our easy case, right? What two numbers multiply to the last but add to the middle? That'd be 9 and 5. So I'm going to rewrite it in factored form. Now, these are the exact same polynomial. This is just in factored form, and that's multiplied out. But they want to know what makes this equal 0. Well, I can't tell from this form, but look here. I have two things that are being multiplied to 0. So either this one under my finger is 0, or this one is 0. And so either this is 0, or this is 0. And so if you solve these, my answers are negative 9 or positive 5. And it's kind of easy to tell here, but I mean, if I went up here and put 5 in, 5 squared is 25, plus 4 times 5 is 20, minus 45. What does that equal when I put it all together? 0. 5 makes this equation equal 0. Same thing here. If you put a negative 9 here and here and you did the math, it's going to come out to 0. And a visual of this problem, right? This is asking when does this quadratic, which it looks like it probably looks something like this. Okay? That's what it looks like. When does it equal 0? Remember, those are called the zeros or the roots. And you can see them right here from factored form. This is why we like factored form. Okay, let's try another one. Again, this one, it's not being multiplied together. There's no way to combine x squared and x, so my only hope is to rewrite it in factored form. And by the way, if you don't like this on the left-hand side, you can rewrite it like this. So what two numbers multiply to 3 and add to negative 8? Nothing. What are we going to do? So in Algebra 2 and maybe even in Algebra 1, when a problem is not factorable, or even if it is, you can still use it. There's the quadratic formula. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you have to memorize that? No. It'll be on the board. Okay? And your a, b, and your c are the numbers right here. This is your a, this is your b, this is your c. Okay? So no way to factor this, no way to combine those. The only hope is quadratic formula. So we have x equals the negative of b, so that'd be positive 8, plus or minus b squared. If this is negative, please be careful. Either, you know when you square it, you're going to get a positive. But if you're going to type this into your calculator, make sure you put it in parentheses. minus 4 times A is 1 and C is 3, all over 2A. Okay? Personal advice, if you're going to use a calculator, type just this in under the radical. Don't type the radical in. I'm just going to show you with my calculator. Negative 8 squared minus 4 times 1 times 3, 52. I'm not typing the square root in, all over 2. So now my answers are 8 plus the square root of 52 over 2, or 8 minus the square root of 52 over 2. You can leave the answers like this. You could break them apart like this. There's this one and this one. And we could also get decimal approximations. Let's practice that. 8 plus the square root, 8 plus the square root of 52, enter, divided by 2, so about 7.61, or 8 minus the square root of 52, divided by 2, is about 0.39. What are we finding again? We're finding the values that would make this equation equal 0. And also, visually, these are the roots. If you were to graph this on Desmos, this is where it's going to be touching the x-axis. Okay? All right, letter C. This one looks like a real mess. I've got x squared in multiple places, and it's not set equal to 0. So remember, our goal is to get it set equal to 0 so we can factor it and use the zero product property. Or if we can't factor it, then we could do the quadratic formula, but it has to be set equal to 0 before I can use the quadratic formula too. You can't take your A, B, and C until this side is 0. So let's clean this up a little bit. I'm going to minus 4x squared from both sides. I'm going to do this all at once. I'm going to add 11. And now I'm going to rearrange it. So that would make 3x squared, those are gone, plus 14x minus 5. So now, this looks like a more difficult one to factor. If you're not on board with that, you could just go straight to the quadratic formula. There's your A, there's your B, there's your C. I'm going to promote factoring. I don't know if it factors, but I'm going to try. I know this times this makes this, so that's 3x and x. And I know this times this makes this. Well, the only way to make that is 5 and 1. So let me drop these in and check. 15 and 1. Can 15 and 1 make 14? Yes. Positive 15, negative 1. Now look, I have something times something equals 0. So either this one equals 0 or this one equals 0. So I write those out. 3x minus 1 equals 0, or x plus 5 equals 0. So now the solutions to this problem are x equals 1/3, or x equals negative 5. And if you did the quadratic formula, you would get those exact same answers. You know, what is this? Once I got this cleaned up, this is saying when does this quadratic, where does it cross the x-axis? Up here, it's when does this quadratic run into this quadratic? Apparently in two different places. We could look at that later with Desmos. Okay, last one. Again, this is a quadratic. I have an x squared and an x. There is no way to combine and get x alone when you have an x squared and an x unless it is by multiplication, right? By factoring. So I'm going to get everything on one side. I don't like my x squared negative, so I'm going to bring this over here. Right? And now that's 0. But I like writing my 0 on the right-hand side, so I'm going to go x squared minus 7x equals 0. Okay, that's kind of an interesting one. Is there a GCF? Yep. And now look what I have. I have something times something equals 0. So So either this is 0 or this is 0. So either this is 0, nothing to solve, already solved. One of the answers to this problem is 0. 0 makes this equation true. And the other solution is 7. And I mean, just try it. If you put a 0 in here, that's 0. If you put a 0 here, 0. Yep, 0 equals 0. If you put a 7 in here, 7 times 7 is 49, and 7 squared is 49. These are the two numbers that make this equation true. Okay? So just at the bottom of this, we're just going to write the quadratic formula just so you have it. When I come back tomorrow, there is actually a song that can help you memorize it. Again, you don't have to memorize it. It'll be on the board, but I believe you'll use it so much, you probably will start to memorize it. Okay, so x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And we get these numbers from a quadratic in standard form. A, B, C. Okay? I wish you good luck on the homework, and I'll see you soon. Bye-bye.